Good afternoon, everyone. Thank you for being here. I know it's a late slot, and I'm probably the only thing keeping you from your last happy hour or dinner and drinks, and so I'll try to keep this as brief as I can. I realized, like literally just now, as I was up here, that I forgot to put a title slide. So we're just going to pretend when I'm starting to get into the preamble that it says Emotional Congruence at Scale. Before that, though, just a reminder to complete your survey after the course or after the session. Okay, so when's the last time that you guys were watching a show or a movie and you were fully immersed, and then an ad break hit and it broke that spell? You could imagine watching like a tense thriller and then a commercial for a beach vacation comes up and you're like totally pulled out of whatever headspace you were trying to escape into. That disconnect's not annoying just for you. It's also wasted money for an advertiser who just spent money at best on an ad that you won't remember and at worst on an ad that frustrated you. And so at NBCUniversal, we're using Databricks AI to try to fix this, to align ads with the content around them, to keep viewers in the moment, and to help make every ad placement more effective for advertisers. My name's Alex, and I'm a director of data science at NBCU in the ad sales division, where I focus primarily on audience science and applied ML in support of the various products that we offer our advertisers. This talk in the next 30 or 40 minutes is going to be about a system that we've built using Databricks AI, so MLflow, Unity Catalog, foundation models served on Databricks, to solve a problem that I think is just now being addressed in the TV ad industry, and that's emotional context matching between an ad creative and a piece of content. I'm here primarily to tell you how we're doing this, to give you insight into the tools that we're using on Databricks, and maybe you can apply them to your own use cases. But I can't really do that unless I tell you the why. And so before I get into that, let me explain to you what I even mean by emotional congruence, emotional context, and why that matters to NBC. Historically, effective advertising has been about two things: getting an ad in front of the right person at the right time. The industry spent a lot of money on doing this effectively. Even in a cookieless world, there's identity graphs that map device IDs to a household. There's programmatic delivery. There's dynamic ad insertion, frequency caps. There's an entire ecosystem that's really mature and really good at solving the problem of getting an ad in front of the right person at the right time. But more recently, I think there's a third component, and that's context. We've heard a lot about it. And that's more about not only the right ad in front of not only the ad in front of the right person at the right time, but the right ad in the right moment in front of the right person at the right time. And that I think remains largely unsolved, and it's where I think the biggest opportunity is. And I think it's a problem legitimately that AI can help us solve. Context here isn't just about like brand safety. It's a more fundamental question of, does this ad belong here? Does the content set the viewer up to receive the message in a way that makes the ad hit harder? Historically, genre and keyword matching might have filled this void, and it kind of gets you into that neighborhood, but they don't really capture how a show makes you feel, and that's really what shapes your mindset when your ad hits. Emotional congruence, what is that? At NBC, we define that as the degree to which an ad's emotional signals align with the content surrounding it. I'll explain what those signals are in a little bit. But know that we're not doing this just to do it. This isn't an exercise in futility. There's a lot of research that suggests that, when content primes a viewer's mindset or emotional state to match an ad's, that the ad performs better. And that makes sense. If you go back to the thriller and beach commercial example, the less that you have to shift your mindset, the better. The more memorable that ad's going to be, the better recall you're going to have around it. And so we're trying to operationalize that at scale. And if we can do that, we'll have unlocked a new layer of targeting around emotion. I mentioned genre keyword matching kind of historically serving this purpose. If a show's classified as a comedy, the assumption is that you're in a lighthearted and receptive mood. If it's news, then you're attentive and engaged. It's a helpful heuristic, I think, and it's worked, but it also is blunt and it lacks nuance in its course. Two shows can be classified as dramas and feel completely different. Breaking Bad and This Is Us, for example, are both dramas, but I'd argue if you're familiar with the shows, you're probably in a really different state emotionally or mindset when you're watching them. And the ads that run in each should reflect that. The genre doesn't necessarily capture that nuance. So what does? What signals emotionally am I talking about? At NBC, we've settled on three main dimensions that we think together capture a fuller emotional profile of a show. And those are themes, tones, and values. Themes answer what a story is about. Is it uplifting? Is it dark? Is it suspenseful? Themes answer what a story is about. Is it romance? Is it coming of age? Is it personal struggle? Tones answer how you feel when you watch it. Is it uplifting? Is it dark? Is it suspenseful? Values answer more broadly what it says about the world and by extension, the audience that watches it. Is it indulgent? Think, Real Housewives and some of the unscripted Bravo content. Is it reflective of family and community, of ambition, success, of safety? And we didn't just craft this taxonomy out of thin air. It was a thoughtful exercise where we started with a really broad library of hundreds of keywords. We embedded them using a BERT-style model, and then we let unsupervised clustering tell us what the natural groupings were. We used pretty standard metrics of cluster evaluation, such as silhouette scores, to help us, help guide us and tell us how many clusters there might be. And the results of taxonomy that's grounded in rich semantic meaning and not just editorial opinion. We validated the clusters manually and gave them definitions so that we could apply them consistently throughout our tagging pipeline. And so with that said, let's get into what this pipeline looks like, how we tag this, and specifically where we're using Databricks. The pipeline consists primarily of two tracks, one for content, one for ads, and it runs symmetrically on both sides of the match. So content goes through signal extraction, and I'll talk through what signals we're actually using in a bit. Synopsis summarization, and then metadata tagging with our emotional signals using foundational models served on Databricks. That produces a dense embedding of each show's emotional profile. The ad tagging works in a very similar way. The difference here is that we're actually using the actual ad, the creative video. An ad spot's only 30 to 60 seconds, so it's fairly cheap to do. So the difference here is that instead of synopsis sources, we're using we're extracting frames from the ad, and audio transcription, we're combining that into a synopsis and tagging that. Once we have the embeddings and tags, we'll just match those across both sides to surface the most congruent show placements. We'll take those titles or those IDs, we'll package them up, and then we'll send them downstream for activation. All this is governed in Unity Catalog and MLflow. In terms of the signals that we're using here, for content, we use a multi-source approach that includes first and third-party synopsis sources. Those all get fed into a prompt and a foundation model that's been tested and chosen to produce a structured synopsis that's optimized for tagging, not just a description of the show. For ad, again, it's multimodal. So we'll track frames at 1 to 2 seconds, so maybe 15 to 30 per ad. Transcribe the audio, package that up into a synopsis, and then that goes through, again, a model and prompt that's been chosen specifically for the ad tagging use case. And then we match them. All of this runs as a Databricks job. In a pipeline, it's a multitask job that runs linearly, so each task is linearly dependent on the prior. So first you have synopsis generation, and then content tagging, and then creative matching. This job runs on a standard cadence, so that we pick up any new shows that have come out in, say, the past week or month on Peacock or any other endpoints that NBC has. We also have a set of evaluation runs. The evaluation runs help choose which prompts and which models we're using for tagging, and I'll walk through that framework in the next slide. Those run kind of offline though, because we're not needing to evaluate the prompt or the model every month. We run those roughly quarterly, and then we'll just promote, if a new model or prompt is chosen, we'll just promote that to our production job. But MLflow tracks every prompt configuration, every run, every evaluation run, every model version. The winning models and prompts get promoted to Unity Catalog, and then we update a configuration table in Unity Catalog. So if we ever need to change the model or change the prompt, we just change the table in Unity Catalog, and nothing else changes. We don't have to change the job. There's no code changes necessary. It's just all pulled from Unity Catalog, and that's made it really easy for us to do this because everything's config driven and fully observable and reproducible. The evaluation itself, framework, is largely a four-step process, but it runs identically for every stage of the match. So we have evaluation of prompts and models for synopsis generation. We have one for content tagging. We have one for ad matching. It starts though with selecting prompt variants. So we might have 3 to 4 prompt variants within a stage, say for synopsis generation, and the differences between those prompts aren't just like small wording changes. They're fairly, there's a strategy behind them. And so one prompt might just very simply, hey, give me the synopsis for this show. Another might employ more chain of reasoning, like first, what emotional state might the viewer be in, and then give me tags for this show. Another might be from an advertiser's frame of mind. We'll ask the model to adopt an advertiser frame of mind. So we have different prompts for within each bucket, and the prompts are designed to extract the structure that we want from the signals that we have in each bucket. We'll then test each of those prompt variants against a set of foundation models. So we might have 3 to 4 prompt variants. We'll test those then against 3 to 4 models. Typically, they're the foundation models, the big 3. It's GPT, Claude, Gemini. We'll test them at pretty deterministic temperatures so that results are reproducible across runs. But the result ultimately is a winning combination of a prompt and a model that's specifically designed to do what we want it to do, whether that's generate a synopsis or tag a piece of content or tag an ad. What defines the winning is it's assessed against a human labeled ground truth. So we're pretty fortunate at NBC to have some resources that do content tagging. And so there's other contextual efforts beyond just this. And so we have a fairly rich set of titles that have been human tagged and verified. And so we'll assess the models and prompts against that human tagged ground truth. Fairly standard metric, we'll use F1 score, a 75% threshold, which I think is relatively normal in the literature. And so every evaluation run is logged to MLflow. We log the prompt artifact, model parameters, the evaluation metrics. So we'll have complete lineage from eval run to registered model to production output. Again, if we want to update or refresh the production model, whether that's because a new frontier model version comes out or because our taxonomy's evolved, or we just want to try a new prompt, all we have to do is run the eval and then update the config table that's in Unity Catalog, and that reflects in the production job. No notebook edits and no redeployment. And so the result here then is basically every ad creative or every title is tagged, and every ad creative we have is also tagged, and we can match those at scale. So, for example, take Yellowstone. I think it's a fairly unambiguous show. Everybody here is probably really familiar with it. Even if you hadn't seen it, you can attest to what it's about. So, I think it makes sense that it would be tagged with gritty, tradition, suspenseful, right? And you'd imagine that the top creative matches that might want to run in that show would be maybe a truck brand, maybe it's an alcohol brand, maybe it's a whiskey, maybe it's a workwear brand. All of these have very similar brand ethoses that you would, again, imagine would run running in Yellowstone. So it makes sense intuitively. But I think the more important piece here is the scale at which we're able to do this. We've tagged over 10,000 titles with relative ease, and there's no code changes that have needed to be made at all. We've set our notebooks up to run, and we haven't had to change those in months because everything is deployed via Unity catalog. So that's where we are now, but I'm really excited about where we're going to go in the future. I think right now, a lot of what we're doing is deploying foundation models via UDFs. At NBCU, we have a fairly strict governance team, and so a lot of the stuff that's available in public preview we can't quite use yet. So once it becomes generally available, we will start to shift this architecture over to use information extraction, which is an agent brick, or AI extract, AI classify. These are all native sort of SQL functions, AI functions that are good at batch processing. If you guys are familiar with them, I hear they're pretty powerful. Again, I can't use them yet, but so the goal is to shift this process over to run in those, and ideally, I think that's going to really make it much easier than it is now. Not that it's hard, but right now we're batch process. Right now we're running these jobs in their UDFs, and so every title there's a foundation call for every title and every instance that we need to tag. There's a call to the model, and so if we shift this over to batch processing, we don't need to worry about that anymore. So it's going to significantly reduce our cost. That's it. I told you guys I would try to keep it short and sweet, and I think I did.